Alright, in example number 6 we have this particular line where this is 280 miles per hour and 38 miles per hour, and that's 60 degrees, and I need to know what that vector is, and I need to as the velocity, and I need to know the speed, which means I need to know how long that is. So let's just focus in on the part that I don't know. Since this is 280J, that's the easy part. So when I make this picture, and this is 60, and this is going to be 30. And this part's 38 because they told us it was 38. Since we have a 30, 60, 90 triangle, this part over here is 19, and this part is 19 square roots of 3. So my velocity is 19 square roots of 3I, because that's as far over to the left as I'm going. And then this is going up north, and this is going up north, so I'm going to put them together. So we got 299J. In order to find the true speed, I'm going to do the Pythagorean theorem of sorts, where I'm going to add these two together and take the square root, and that will give me the speed, because speed does not have a direction. This turns out to be the square root of 90484, and that turns out to be 300.8 miles per hour. Alright, for the next problem, we have a river that's flowing that way at 8 miles per hour. And you have a boat that you need to be traveling at this direction, so that actually the boat will go directly across the river. But you need to travel 16 miles per hour, and part of that has to be upstream, so that you don't wind up having a problem getting to your desired landing point if this is A and this is B. Since we want this to be perfect, and I know that the purple one is 8I, I know that I want the blue one to have negative 8I. So this has to be negative 8I. This has to be 16. And so how far am I going to go in this direction? Well, once again, if I needed to do this, I could do arc sine, not arc sine, but arc cosine, because this is adjacent, and hypotenuse of 8 over 16, and that will tell me that it is 30 degrees. No, it won't. It'll tell me that it is 60 degrees. Because once again, this is a 30, 60, 90 triangle, where the 30 is up here and the 60 is down here. And if I do the Pythagorean theorem, this side turns out to be 8 square roots of 3. So if this is straight across or straight north, then this is going to be 30 degrees. So I am going to have to paddle 30 degrees upstream in order to get my boat all the way across. And since I really didn't know this was north, but we'll just say 30 degrees upstream, whichever way upstream happens to be in this problem. Alright, so in the notes they didn't give you the picture, so I gave you the picture for number 8. We have two forces acting out on an object right here at P. And for the resulting force, we want to figure out how far it's being pulled horizontally and how far it's being pulled vertically. So for the first one, when I have 45 and this has a force of 6, if I do tangent of 45, not tangent, sorry about that, sine of 45 equals x over 6, it turns out to be, x turns out to be 4.24, and this turns out to also be 4.24 because this is a 45, 45, 90 triangle, and so we know that everything is the same. For this other one, this is going to turn out to be 60, and the force over here is going to be 24, and so we can either do it the same way, or we got a 30, 60, 90 triangle, which means this down here is 12, and it's negative because it's going to the left, and up is going to be 12 square roots of 3, which, since we're rounding, I'm going to make equal to 20.7 or 20.8. So for my x coordinates, I have this one and this one, so I got negative 12 plus 4.24, which equals negative 8 for I, and then I have let me use yellow here. I got this 20.8 and this 4.24 all in the same direction going for y. So 20.8 plus 4.24, when I round it to the nearest integer, is 25. And so my vector is negative 8i plus 25j. And so that was the 3 problems that we hadn't gone over in 8.1 for those of you who are going to miss on Monday or Tuesday for any reason. I meant 9.1 if I said 8.1.